Hello everyone. In this video, I'm going to discuss the concept called hash table. Coming to this hash table, so we are going to represent this hash table, which is going to implement which will be mapping the keys to the values. Okay, so here we are going to map the keys to the values in this hash table. So coming to the declaration of this hash table class, so we need to make use of this package called java.util.hashtable class. Okay, so after that means after declaring this package, then we need to specify public class hash table. Okay, so then we need to represent the keys and then values, and then we need to extend the dictionary keys and values, and it is going to implement map keys and values. Okay, along with this map, it has to implement the another interfaces like clonable and then serializable. So this is how we are going to declare the hash table. Next, coming across with the parameters called k and then v. So this k is nothing but it is a type of keys that is maintained by this map. Okay, and v is nothing but it is a type of mapped values. That means k is nothing but the keys over here and v is nothing but the values. So where whatever the mapping we are doing with this keys to values, that we are going to represent like a parameters for this hash table. So this is an example which is going to demonstrate with the hash table. So here we are going to import the package called java.util. Okay, and the class name is hash table one, and here I'm going to write the main method. And here I'm going to represent hash table, and then keys and values is integer and then strings. Okay, and creating an object and then a new hash table. Here I'm trying to put, that means here I'm trying to insert some values into that hash table, that is 100 Amit, and that means 102 Debbie, and then so 101 Vijay and 103 Rahul. Okay, see here I'm going to set like map entry hm.entry set. So this is a method so which is going to repeat this process, and it has been that means this will be entering the values into that hash table, so in a sequential order. Okay, and that too in the so whatever the things we have entered, it will be represented in the beneath of the table. Okay, that means it will be in the from the top we can say it will be in the last line, and in the sequential order, no, we are saying like, so this one after this 100 it will be the 101, and above that 101 will be having 102, and above the 102 will be having the 102. So if we try to print the statement called get value, here the output will be like this. See, whatever the thing I told you, like, so even though we have represented the things like this based on the integer, it is going to take the values in a sequential order, and it will be representing in a below to, that means bottom to up order. So this is the hash table. Even though we have inserted the 100 and Amit value at the first value itself, but it has been represented in the table in the last row. But here, if you observe, along with this first in last out representation, so here it is going to represent the values in a sequential order. Okay, that means after this 100 representation, it is coming with 101. But we have, whatever the value we have entered, we have inserted into the hash table is after 100 we have inserted 1 or 2, after that we have inserted the 1 or 2. But if you observe over here, it is in a sequential order, that is in a bottom to top position. Okay, so next this is how we are going to make use of a remove method in this hash table. Okay, so in the last program I have tried to insert some values into that hash table. Okay, that means by making use of a put method. Okay, now I'm going to make use of the remove method. Okay, the same thing I'm doing, whatever the representations we have come across in the previous example. So up to this is the same. Okay, here I'm trying to print that values. Okay, after that, here I'm trying to apply remove method. I'm trying to remove the value called, that means remove the key called 1 or 2. Okay, after removing this 102, again I'm trying to print that hash table values. Okay, so if you observe the output here before remove, we'll be having the same order. That means from bottom to up, we'll be having the 100, 101, 102, and then 103. Okay, so here after performing this one, we are trying to remove 102. No, so if you observe this after remove statement, we will be getting the values. It will be printing the values without 102. Okay, so if we are going to remove the key, in the sense for that key, whatever the value it has been assigned, it is also get removed over here. Okay, so that's why this is the specification which is showing us before we use the remove method, and after we will be using the remove method. Next, get or default method. So in this one, here the specification is same. So just like we are going to represent this insert, we will be inserting the values into that hash table, and then here I'm going to get the value of that particular key. Here I'm going to specify the key over here, and I just want to know what is the value for that particular key. See, I can able to specify either get or default. Okay, so map dot get or default for the key called 101. Okay, if it is not found in this is, then it has to display not found. Okay, so in this way I have specified for 101 and 105. As we are having the 101 key over here, it is going to display the value called vision. Okay, and as we are not having 105 key over here, it will be displaying the output like not found. Okay, so this is how we will be, that means it will be representing the output if we are going to make use of a method called get or default. Okay, so in this hash table, we have used with three methods called, okay, so put method, that means for inserting the values into the hash table, and the remove method for removing the keys from the hash table, and the third one is get or default, that means for the specified position, or else for the specified key which we have mentioned, we will be getting the value for that particular key. So if it is not finding that key value, in the sense it needs to display the not found as an output. Okay, so next with the properties. Okay, so here we are going to represent the properties, so which is going to denote the persistent set of properties over here. Okay, so for defining, to get the information from the properties file, first of all we need to create the properties file first. Okay, so whenever we are trying to attain the properties, okay, first of all we need to create the properties file first. So for that one, we are going to define user is equal to system and password is equal to archive. Okay, so now we are going to create the Java class to read the data from the properties file. See, we have already created the properties file, and now we are trying to read the, that means now we are trying to read the data from this properties file by making use of this Java class. See, so here we have imported this java.util package and java.io package. Okay, and then we have mentioned with this main, and then we are also representing the throws exception. Okay, if it is not found in the sense, then it has to throw exception. No, so that's why we have represented the exception also. Then as we are trying to read the file, so here I'm going to represent a file reader. Reader is equal to new file reader. And what is that file name? That is nothing but db.properties. No, here I'm going to mention the name of that file called db.properties. Now I'm going to create the object for that properties file. Okay, next, based on that object, p.load. Here I'm trying to load the things, that means properties of this file. No, so just I'm going to represent p.load reader. Okay, next I just want to print that I'm trying to get the property of this properties file. So one is with the user and p.get property, and second one is the password. Okay, so if we are trying to display this one, so the user, what is the user we have defined? It is a system, and what is the password? It is a archive. So if you try to run this program, we will be getting the output like system and then archive, which are nothing but the properties, so which has already defined in a file called a db.properties file. Okay, this is how we are going to get the information from the properties file by making use of this properties. Okay. Next, coming with how we are going to get the information from the system. Okay, so in the previous slide, so we have come across with how we are going to getting the information or else getting the property from a file. Here we are trying to get the information from the system. So for that one, just we need to represent the system.getProperties. Okay, so this is a method which we can use to get the properties of the system. Okay, so this class is going to create the class that gets the information from the system properties. See, the same thing we are going to define properties P is equal to system.getProperties. And here we are going to set the entry set and it is going to represent the iterator. That means it has to read the next value. No? So that's why I have represented the condition called while itr.hasNext. Okay, and next it is going to represent the map entry for that each and every iteration for the next. Okay, next finally it is going to give the entry.get value. That means here we are trying to get the key along with the value over here. So it is printing that key and then value in this whenever we are trying to get the properties of a system. Next, coming with the concept called stack. So we know that stack is nothing but, so we here in this collection framework, we are going to provide the stack class. So which models and implement the stack data structure. Okay. So we know the basic principle of the stack, that is last in, first out. Okay, so whatever the values we are inserting the first, it will be in the last position. So that's why we are saying that it has a last in, first out. Okay, so generally in this stack we are very much familiar with the operation like a push and popping. So push is nothing but inserting the values into the stack and pop is nothing but removing the elements from the stack. Okay, along with these basic operations, we are also coming across with the three more functions called empty, search, and then peek. Okay, so coming with this so empty or else search in the sense. Okay, so here the search is nothing but general search only. So whatever the element which we want to search, it will be searching that element in the stack. Whereas coming to the peek, so peek function is nothing but it is going to return the value of the top of the collection without removing the element from the collection. Okay, see if you remove the elements from the collection, then obviously the pointer will be the at the top, right? But here if you use the peek in the sense, it is going to return the value of the top of the collection without removing the elements from the collection. Okay, that means here we are not removing the elements, but still it will be representing with the value called top of the element which is existing in the stack. Okay, next coming to this empty. So this empty method is going to use to check whether the associated container is empty or not, and it is going to return true or false accordingly. Okay, so it is going to check whether this particular container is empty or not. So along with these basic operations push and pop, we are also making use of empty, search, and peek in this step. Okay, so the class can set to be a extend vector and also treats the class as a stack with the 5 mentioned functions called, so this one, vectors, okay, list, collection, and then iterable. Okay, so this will be specifying the hierarchy of the stack class. So this is the stack class, so which will be extending the vectors, and this stack class is going to implement the interfaces. So it is going to implement the interface called list. Again, this list is going to extend the collections, and this collections is going to extend the iterable. So these are all the interfaces. So this is the hierarchy of the stack class. And coming to this example, this is the simple Java code for stack implementation. So where we are trying to push and pop the elements. See, so I'm just trying to insert the 5 elements into the stack. So I'm coming across with the for loop for I int I is equal to 0, I less than 5, and I increment. And I'm trying to insert that I values into the stack. So for inserting, I'll be using the method called push. And again, I'm just trying to pop the elements from the top of the stack. Okay, so here I'm just representing the pop method. Okay. And here I'm going to specify the integer value, which that means which elements I need to pop the element from the stack. Okay. After that one, it has to display the element on the top of the stack. So whatever the element that is representing that is pointing to the top, that element has to get displayed. Okay. Next, if I want to search any element in the stack in the sense, then I'll be making use of the search method. And here I'm going to represent the position. Okay, so if it is having that element in the sense, then it is going to display that element. Otherwise, it is going to represent the thing like element not found. Okay, so if found in the sense, it has to display the position of that particular element. Okay, so this is how I'm going to represent all the methods in that stack, and I'm going to represent the main method, and whatever the methods I have specified here, I'm passing that values. Okay, so if I try to run this program, I'll be getting the output like this. Okay, so I'm trying to something like I'm trying to push the elements into the stack. After pushing the elements, okay, so I'm trying to pop the elements, and after that I'm going to specify the peak elements, and then so this is the peak element on the stack top is 4. Okay, and here element is found at the position. Here I'm just specifying that my position. No, that means I'm going to specify the value. No, so that value is at the position 3. Okay, and then so if it is the element is not found in the sense, then it is going to display the statement like element not found. Okay, so here this is the peak, and this is the representation of the peak element, and then these are the pop elements from the stack. Okay, so these are all the operations which we can able to process in the stack. Thank you.